Hi guys, and welcome to the mole. So if you're ready, we'll go ahead and get started. Okay, so today we're going to talk about the mole. All right, so the mole, a couple things important about it. It's what they call the SI unit of quantity. So SI stands for Sistema International, so that's the international unit of measurements. Right, so for instance, for length, we have the meter, because that would be the best length for measuring us, because it's all about us. Weight, we'd have the kilogram. Right, so that's a standard unit of mass. For time, we'd have the second, because that's the best unit for measuring what's right now. And then for quantity, we have the mole. And the mole is a way that we can measure atoms, because atoms are so small they're hard to be measured. So it can be used to convert between quantities. So a mole can be used for volume, it can be used for mass, and it can be used for quantity, or what we call particles. Let me erase that. So we can use the mole to change between those three values. And there's nothing else that we can do that does that. So we do mass, volume, and particles. So there was this guy named Avogadro. So Avogadro figured out how to put it all together. So what Avogadro figured out, that for volume, 1 mole of any substance is 22.4 liters. So the mass of any substance, let's move this over a little bit, is the AMU in grams. So we're going to talk about that. And particles, a mole of any substance contains 6.02 times 10 to the 23rd particles. And this is called Avogadro's number. So he was able to tie all these together to the periodic table, which we're going to talk about shortly. All right, that's what I talked about right here. Right, 1 gram. Right, and that mole of gas for 22.4 liters is at what they call standard temperature and pressure, STP. We'll talk about that. So when we look at going between these different units, it's important to remember that the mole is in the center. So if I want to transfer particles to grams, I got to go to moles first, and then I go out to grams. If I want to go from grams to liters, I got to go through mole to get to liters. So the mole is going to be our central unit for conversion. And it's pretty easy. I'll show you how to do it. So first thing we're going to talk about is molar mass. All right, so the molar mass is its atomic mass in grams. So atomic mass, remember, so atomic mass here is the AMU. So it's the atomic mass unit. So for instance, if we take helium here, let me expand this. So the periodic table I gave you is probably the one you should use. Make sure you print it out. I have that in required forms. So if you look at this bottom number here, this number right here, right? So that's the atomic mass. So 4.00 AMU. So what Avogadro says is the molar mass is equal to 4.00 grams. So if you simply make the AMU a gram, that's the molar mass. So if I have 4 grams right, that'll contain it'll contain 6.02 times 10 to the 23 molecules and occupy 22.4 liters. Right, so if I have 4 grams of helium, it contains that many molecules, and that STP will be 22.4 liters. So that's how he ties it all together. Right, so molar mass right, is simply the AMU in grams. So that should be pretty easy. So if we start to, let me erase this. If we start to go through our periodic table, so if you look at your periodic table, and you should have it out, nitrogen, so if we look at the mass of nitrogen, right, so nitrogen is 14, so it's simply, so that's that big number at the bottom of the periodic table. Look over at the periodic table now. Right, so the AMU in grams, that goes from atomic mass to molar mass. So nitrogen gas, which is going to be N2, right, sorry, the subscripts don't work well. So N2 is nitrogen gas, right, because a lot of the gases, and I'll talk about those a little later, only come in a diatomic form. So the atomic mass from here, since there's two of them, so the subscript is a multiplier, right, would be 28.02, right, and so 20 grams. For formula weight, right, so formula weight, hold on. Formula weight and molar weight are essentially the same thing. So if we look at sodium chloride, right, so I think I had this written down, I didn't. So sodium is 24.31. So the easy way to do these, if I'm going to 22.99, and chloride is 35.45. So I get 58.44 grams, right? The atomic mass would be AMUs, that would be grams. So aluminum oxide, again, let me give you the subscripts here. Oops, that's wrong. And you'll learn how to do that in first semester. Okay, so aluminum oxide, Al2O3. Remember, these are multipliers here. So the way to do that, if you're writing out your work because you want credit for it, is 2Al and 3O. So 2 times aluminum. Each aluminum is 26.98, so you have 59.36 of aluminum. Each oxygen is 16. So if I have 3 oxygens, I have 48. And then I get 107.36. Right, and so that would be so that's simply what molar mass is. This one, I just want to give you an example. Those would be the subscripts for that. So ammonium chloride. So the important thing to remember is this 2 here gets distributed to the whole problem, or to the whole parentheses. So if I was going to write those out here again, let me write my, so I have N, H, S, and O. So those are all the different components. But now I have 2 N's. I have 8 H's because that 2 multiplies to 4. I have 1 S, and I have 4 O's. Right. When you do that problem, you're going to come out, if you want to do it on your own, you come out with 132.17 grams. So if you want to make sure that you can get the right answer, but that's how you do it. So we multiply those. Right, with the multipliers, I get those masses, and then I get that. Okay, so let me erase some of this stuff. and we'll move on. Oops. So we did all that to figure out how to do molar conversions. All right, so this little road map here, they call this a road map. This one right here. Oops. So this one right here. So this is an important road map because as you see, the mole is in the center again. And every time we go in each of these right here are conversions. So if you can have a picture or a snapshot of this, when you do your quizzes, remember all your quizzes are open note for summer school, make sure you have a picture of that, right? Because that'll show you the conversion factors to move from moles to volume, or moles to particles, or moles to mass, or to move from mass to moles, or particles to mold, or volume to mole, right? So these are conversion factor. So, sorry, we'll start to move on. So remember, the mole is the central unit, okay? So it's in the middle of everything. So if I'm going from moles to gas, then I'm going to multiply by 22.4. If I'm going volume to mole, then I'm going to divide by 22.4. So whenever you're going away from mole, you multiply. Whenever you're going towards, you divide. So when you read problems, right, so remember the unit of volume is liter, right? The unit of mass is going to be grams. But particles, right, or anything that's real, right? So particles are real. So we have molecules. We could have atoms. We could have units. We could have compounds. So anything that's real is a particle, right? So if I say, give you a problem here, I'll show you how to solve these. How many moles are there in 50 grams of methane? So the important thing here is to figure out where the start and where the end is. So this right here, how many moles? The question is the end. This is the end. And the given is always the start. So the given is anything with a numerical value that's used in the problem. So start and end. So here I am. I have grams, so that's mass. So this is my start. And my end is there, right? So I'm going from mass to mole. Right? So the way we do this, or the way I do this, is I draw one of these. Right? My given always goes up here. So 50. By 50 grams of CH4. Right? And if I look at my conversion, if I'm going here, I have mole. Right? That's the abbreviation for mole. And I have to put the molar mass. So if I go to the periodic table and I add up the molar mass, I get 16.06 grams. Right? And so when I divide these, right, I'll get, oh, and for those who have never had me, whenever you see a line like this, it means multiply. All right? Right? And that's just the numerator denominator symbol. Okay. So when I multiply these, I get 3.11 mole CH4. Right? Because you'll notice that my grams cancel out. Right? So not too hard. We'll continue on our Avogadro journey here. So how many molecules? So if I look up here, I started with 50 grams, and I'm trying to find particles, but I've already gone to mole. So since I already know mole, I can simply now go from moles to particles. Right, so that's how we read the roadmap. So I know that I already have 3.11. So that's my new start. And my end is molecules. And molecules, remember, are particles. Right? All right, so if I looked at my conversion, I'll put my mole there. Whatever you want to cancel should be opposite. And then I'll simply put Avogadro's number here. All right, so when I multiply those, I'll get 18.7 times 10 to the 23rd. But that's not or that is incorrect for scientific notation. So scientific notation says I have to have the decimal after the first real number. All right, so we're going to rewrite that. Like that. All right. So how much volume will it occupy? All right, so again, I started with mass. I went to moles. I've gone from moles to particles. Now I have to go to volume. I don't have to start at mass. I already know moles, so I'll just go from moles to volume. All right, so I'll start with my 3.11 CH4. I'll keep my mole on the bottom because remember, my mole's in the bottom, I can get rid of it. My 22.4 liters. And I end up getting 69.7 liters of methane. All right, density. It's a different question. So density, notice there's nothing up here on density, right? There's nothing on our roadmap for density. So density is mass over volume, right? I guess I should have been curved like that. All right, so the mass of this, so if I want molar density, so my mass was 16.01 grams, and my molar volume, that's 22.4 liters. Right, so for this, for density, it's molar mass over molar volume. Okay, so when I do that, you'll get 0.7170 grams per liters. I couldn't cancel out anything, and it has to be mass over volume, so I get grams and liters. Okay. All right, that's about it. So for the homework, I'll do another screencast to help you with homework if you need it. If you don't, go ahead and get it done. Your quiz tomorrow will be based on the homework. All right, so look for questions similar to homework questions with different values. So if you can solve the homework, you'll be able to solve the quiz. All right, good luck.